Hi everyone, it's Mrs. Brimlow for the third time with this video. Hopefully my computer does not crash again. Today we're going to be talking about slope-intercept form in real-world scenarios. So if you could turn to page 32 in your packet, or you can print the notes and practice out from Canvas, whatever works better for you. This is also going to be your classwork for today. So I'm going to skip the first problem, and that will be part of your practice, and we're going to go to number 2. And it's perfect timing because ice cream stores are starting to open, so we can really visualize this, take a look at an actual ice cream store, and talk through how this works, okay? However, before we even get there, let's actually go back to the top, and if you could copy this down, that would be great. So we know slope-intercept form is y equals mx plus b, where m is your slope or rate of change, which basically tells you how steep the line is and how it's moving from one coordinate to the next over time. And b is the y-intercept, where the function crosses the y-axis. In a lot of real-world scenarios, we call it the initial value because we don't really work with negative amount of items. Like you can't have -1 eggs or -1, ice cream sundaes. So typically we say the initial value, or where we start, is where x is 0, and then you have some number for y, whether it's 0 or something else on the y-axis. So this is typical, once again, typically the initial amount in a scenario, okay? So in this example, we're talking about ice cream sundaes. So I actually looked up the inside scoop because, fun fact, I've never been before, although I'm hoping to get there this season with my husband one time. And so the function below shows the cost of an ice cream sundae with different numbers of toppings, T. So T represents the number of toppings you're going to get. And then f of t equals, so your total cost equals 2.25 plus 0.75 t. So before we get into this and break this down, I want us to actually talk about, let's say we go to the inside scoop. So if I plan to go with my husband, he would probably just get vanilla. He likes it pretty plain. I would probably either get mint chip or butter crunch. Those are probably the two most appealing to me. I just have to wait and see when I get there. So he would get vanilla. I would get one of those flavors. We'd both pay the same amount if we both got the same size. So there's a base cost to building a sundae. He probably wouldn't want to add any toppings to it, but I definitely would. Standard, I love hot fudge and I love sprinkles. So I definitely want to get at least those 2 toppings. But before we figure out the cost with toppings, we would both start out with the base cost, let's say $3. So we get our cups, we get our ice cream, and then I want to add things to it. So for each topping you add, you're going to pay a little bit more money. So let's say it's $1 topping and I get hot fudge and sprinkles. So it's $3 for my base sundae, just the ice cream. And then $1 for the 2 toppings each would be $5 in total. $2 for the toppings, $3 for the ice cream. My husband, who just wants vanilla, would just pay for the ice cream at $3. So when you're thinking about building things, or when you're starting something, you have your base where you start, and then you can either add or subtract from it. So for me, we'd start with the ice cream sundaes. We'd both be paying the same amount for our base sundaes, but then mine would increase while his stayed the same because I would be adding toppings to it. Okay, so let's take a look at this in terms of our scenario, in our equation. All right, so base cost would be my y-intercept, what I'd start with. And based on the form of this, this is like saying y equals b plus mx. Now I know this just because I know slope-intercept form. And the y-intercept is the constant by itself. So that means that 225 is the y-intercept, or the base of the sundaes before toppings. So we're going to write $2.25 is the y-intercept. This is the base cost before adding toppings, okay? So I would have to pay $2.25 for my sundae wherever the store is. and then we would add as many toppings as we wanted. So what is the slope and what does it mean? So the slope is going to be 75 cents or 0.75, and this is the cost per added toppings. So everyone starts out by paying $2.25 for their ice cream sundae, and then it will increase over time by 75 cents for every topping you add, anything from no toppings up to 10 or even higher, as many toppings as the ice cream store has. Okay. So if Kay paid $6 for a sundae, how many toppings were on it? So we know that this is y equals 2.25 plus 0.75x. So I'm just swapping out the t and f of t for y and x, what we're used to working with. All right, so they say in total the sundae was $6. So y represents my total cost. What we're trying to figure out is how many toppings. So this is what I know, and I have everything I need to solve this. This is just a two-step equation, which you've been doing since 7th grade. So my goal is to get x by itself. So I have to get rid of this constant first. So I'm going to subtract 2.25 from each side, and that's going to leave me with 375 here and 0.75x here. I'm just going to bring this work up over here so I have enough room. So I'm going to rewrite this step. Okay, my goal is to get x by itself, so I do the opposite of what I see to work backwards, and I'm going to divide. So recent calculator, perfect. So I have 3.75 divided by 0.75, which is 5. So that means K had 5 toppings on their sundae, so that their sundae cost a total of $6. Okay. So we just went through the process of looking at an equation and understanding the different parts and what it looks like in a real world scenario. So you're going to go ahead and finish problems 1, and then on the next page 3 and 4. If you feel you need more practice with equations, then you can do some work on IXL. If you feel good, then you can move on and try pages 34 and 35 as well. Okay. And I will chat with you soon.